Hi, I'm Kian, and in this video, I'm going to show you how to solve this multivariable question. So we're given that if a vector valued function, lowercase f, which is given by e to the y comma negative e to the negative y plus cosine of y plus x e to the y, this is equal to the gradient of capital F, or capital F, which is basically a scalar function. We're given the vector valued function, and we're supposed to find this. So first of all, we have to understand this notation. As I explained, it's a gradient. So basically, gradient of a scalar function is the individual partial derivative with respect to each variable. So basically, since we can see that this vector valued function has only two coordinates, it is an x coordinate and a y coordinate if you name it x and y, and we can see that it is a two-dimensional vector. As a result, there are only two variables. There's an x variable and there's a y variable. There's no z, t, so it's only two dimension. And so we know that as a hint that our final answer, our scalar function, should be in terms of x and y, or just one of them. It can be more than two variables. It's at most two variables. And so what we can do is that basically, as I explained, the gradient is the partial derivative with respect to each variable. So this coordinate, which is e to the y, is basically we have our function, we take the derivative with respect to x, and we get e to the y. So if we want to undo it, we have to take the integral with respect to x. And if we do that, we see that y is treated as a constant, and so basically we're taking the integral of e to the y in terms of in the x world, if you want to say. And so y is a constant, so it'd just be x e to the y. And this is the first part. For the second part, or for the second coordinates, I would say in the function, we can see that if we take the derivative of the function with respect to y, we get negative e to the negative y. So if we integrate that with respect to y, we just get plus e to the negative y. Same with the next part. We get plus cosine of y, integrate that, we get plus sine. And the other part is just the first part, because if we take the derivative of x e to the y with respect to y, we just get the original. And just to check, if we take the derivative with respect to x, we get e to the y, that's checked. If we take the derivative with respect to y, we get x e to the y, checked, negative e to the negative y, and then plus cosine of y. And that's it. That's our function. Obviously, we can add an arbitrary plus c if you want, because this is a function. Usually, we're taking integrals, and integrals, because we don't have any boundary, we can add a plus c. It doesn't really matter, because if you take a derivative of a constant, it's just let it be 0. So I hope you enjoyed it, and please subscribe to my channel, and goodbye.